Stop guessing embeddings. Run a benchmark that tells you which model actually retrieves better. By the end, you will know how to measure retrieval quality and pick the embedding that helps your RAG system give better evidence to users. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Retrieval for RAG is where embeddings meet real questions. People reach for embeddings when keyword search is too brittle and they want semantic matches. The pain point is obvious. You swap models and get different answers. You need a repeatable way to compare them, not gut feeling. Success means a clear metric and a baseline you can track as you change models or data. At a high level, benchmarking here means 3 steps. Encode a small corpus, encode the query set, and measure how often the model ranks truly relevant documents near the top. Even with a tiny corpus, you learn about score scales, normalization, and metric stability. That knowledge scales to bigger collections. We will build a compact, repeatable retrieval benchmark using a tiny corpus of 3 short texts and 1 question about converting sunlight to home power. This keeps the example readable while showing the full workflow you would scale later. Now, we'll run a first retrieval to see how a model surfaces relevant text. This snippet performs a first retrieval using sentence transformers to make the workflow concrete. The list docs holds 3 short texts to keep the example readable. The variable m is a sentence transformer model we'll reuse, and d stores dense embeddings for the docs. The string q is our user question about converting sunlight to home power. We call util.semanticSearch with the encoded query and corpus embeddings, which returns ranked hits. The list h is the top k results for the single query. Finally, we map the best hits corpus ID back to the original text and print it. Seeing top doc confirms the model can surface relevant content for the query. Next, we'll swap in a different embedding family to compare raw retrieval confidence. This snippet tests whether switching embeddings helps more than tweaking re-rankers. We load a second sentence transformer model as M2 and encode the same docs into D2. The variables Q1 and Q2 hold the query embedding for each model. We then call util.semanticSearch for both model corpus pairs and read the top hit score as S1 and S2. These scores reflect how confidently each model ranks its best matching document for the question. The variable best picks the model with the higher top 1 similarity. Printing best model gives an immediate signal of which embedding family looks stronger for this query. Next, we'll run a standard retrieval task to get a repeatable metric rather than a single score. This snippet turns single query intuition into a benchmarked score using MTEB. We create an MTEB runner with the SciFact retrieval task, a beer-style dataset focused on scientific claims. The call task.run evaluates the existing model M end-to-end, handling dataset loading, indexing, and scoring. It returns a nested dictionary in res with metrics per split. We extract the nDCG at rank 10 for the test split into nDCG. nDCG at 10 measures ranking quality by rewarding highly ranked, relevant documents. The printed nDCG 10 summarizes how well this embedding retrieves scientific evidence, giving you a repeatable baseline. Next, we'll check how normalization changes similarity scales, so scores are comparable across models. This snippet highlights a pragmatic tweak that affects similarity scales. We first encode the query and docs, without normalization, into Q0 and D0. Then compute S0 as the maximum dot score. Next, we encode with normalize embeddings equals true into Q1 and D1 and compute S1. Normalization guarantees unit length vectors, making dot score numerically equal to cosine similarity and bounded in -1, -1. Without normalization, dot scores vary with vector magnitudes, making cross-model or cross-dataset comparisons unreliable. Increasing normalization usage improves score comparability. Turning it off can inflate raw dot values. The printed norm max dot shows a calibrated score you can compare across runs. Next, we'll run a small multitask check to pick the embedding that generalizes best. This snippet scales evaluation to a small multitask check and aggregates results. We define tasks with SciFact and NFCorpus to cover different domains. Then build a shared MTEB runner. The calls runner.run evaluate M and M2 separately, returning metric dicts R1 and R2. We compute macro-averaged nDCG at 10 across tasks as A1 and A2 for each model. The variable best selects the higher scoring embedding as your baseline choice to track over time. Printing macro nDCG reports the stronger macro score, signaling which model generalizes better across these retrieval tasks. Taken together, this toy workflow maps cleanly to a real project. Replace the 3 texts with your document store and swap the single question set for your user queries. Use the same runner to build and index once, then evaluate every candidate embedding family. Add timing measurements when you scale indexing and nearest neighbor search. Track a single macro metric weekly so you catch regressions when you update models or change the pre-processing pipeline. Recap briefly what it is: a small, repeatable retrieval benchmark that tests embedding choices with concrete metrics. When to use it: whenever you need to pick or validate embeddings for RAG before production. One caveat: tiny toy examples show trends, but not absolute performance. Scale to representative data before final decisions. Next step: tune an ANN index parameter like FAISS, nList, and nProbe while rerunning the same benchmark to see how index trade-offs affect retrieval quality and latency. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.